So Sruti, take it away.
Oh, sorry about that. Is that okay? Morning, and thanks for coming. I'm Sruti Ragavan from Oregon State University. I'm a PhD student. And I'll spend the next 15 minutes talking about our study on information foraging theory for the presence of variants of a program. And all my co-authors, except for Anita, Sarma, or right here in the room, there's Charles there, and the others are sitting around here. So let's get started. Imagine somebody who's using a computer for a creative task. So often when we are doing something creative, we tend to explore a lot of different options. Try this, try that, until we finally figure down on something. And literature shows that programmers also do a lot of such things. Here's an example. Imagine there is a programmer who's kind of trying to build a game, which looks something like this. So there is something with a black background. You can't really see that there, I'm sorry. And then there are all these kinds of different things with different colors, different appearances, and so on. And programmers sometimes also try a lot of different options in order to actually make their game work, right? Now, what happens is when you're on such an exploratory mode, we tend to create a lot of different variants of the same thing. In this case, it's a lot of different variants of the same game program. So why do we care about variants at all? Imagine the same programmer doing the same game. Let's assume he currently has got this version of the game, which looks like the top right, with a red box around it. And let's say he now wants to try out an option where he wants to put the score up above, like the one in the middle, right? So it's kind of intuitive. You might just think, OK, let's go to that old variant, take that thing and stick it back here, and things should work fine. But it turns out that that can be a hard problem. Why? Because there could just be a lot of similar variants, right? One is there could just be a lot, and then these are all very similar to each other. So if you just looked at the things here, like 4 of these 5 different things are all very similar to each other. So finding one among them could be hard. Interestingly, this problem has not been really looked at in depth in programming literature. So we looked at this problem and kind of asked ourselves these 2 research questions. How do programmers identify a variant for reuse? And how do programmers integrate code across different variants? And we kind of use information foraging theory to guide our research. In the interest of time, during this talk, I'll just focus on the first research question. Now, in order to answer these research questions, we did a user study with 8 novice programmers. We chose novice programmers because there's literature that says that they are more likely to go on an exploratory mode, and they are also opportunistic in that they tend to copy and paste and reuse a lot of code. We made them think aloud while they performed a reuse task, and we followed that up with retrospective interviews, mostly for triangulation purposes. Here was the actual task. The game looked like this. There is the score and the multiplier that's in the middle of the hexagon. And we told them to move the score and the multiplier to above the hexagon like it was before. We did not show them how it looked like it was before, but just for the sake of this talk, here's kind of how it looked like. The score and the multiplier were above the hexagon. They were always visible. There was no flashing like you see on the left. And the multiplier was kind of within these little parentheses. Here's how the environment looked like. Don't read it. Just for the sake of, so it's a standard IDE. There is like an explorer, there's an editor, and you can kind of see a preview. For the sake of this task, we provided the participants with all the different older variants of the game, which is what you see on the left. We took the Git repository of the program, and we kind of converted each of the revisions into a variant. We labeled the variants with the timestamp of the change, and we gave it to them in a chronological order, as you can see here. We chose the definition of a variant as an entire copy of a program at that time. So these 2 little bubbles are basically the whole copy of a program, and each one of them is a program in its own. And for analysis, we used information foraging theory. Just to refresh your memory back, we asked people to change a program to look like what's on the left to move the score to how it's on the right. So information foraging theory is this theory of how people look for information. It's inspired from life sciences, and it has these constructs. There's this construct called a predator and a prey, where a predator forages for its prey in the wild. In this case, the predator is the programmer, and the prey is the pieces of source code that he's looking for. The prey might be located in these several locations, which are called patches, and the predator kind of uses what are called cues in the environment, which are like hints that guide the predator to the prey. In the past, information foraging theory has been used to predict and explain how programmers search for a piece of code within a program. In this study, we look at how programmers forage in the presence of several different variants of a program. So in the earlier work, it's just been a single program. Here we just have different copies of it. For a qualitative coding, we used the types of cues that programmers used. We use the cue types that literature has reported earlier. A lot of these people are already in the audience. And we added some more to code the phenomenon that we found specifically here. Recall that the task was to make changes to the score position of this game to look like that. So essentially, they had to take a piece of code from what we call the source, and then put it in what we call the destination. Now, we told programmers to make changes to a particular variant, which was called current, so the destination variant was kind of known to them. Now, within this variant, there are all these different locations or patches. Right? Like I said, a patch is a location within an environment. So the programmer kind of has to find out which exact patch he has to make a change in. So they kind of forage for the destination patches, and prior literature in IFT has done a lot of this work. So once the destination patches were found, the programmer then has to find what the source variant was, right, in order to reuse from, like how the old one looked like. So in order to do that, we did not tell them where exactly it was or how it looked like. So we kind of forced them to plow through these old variants this way. In IFT literature, when there are several different patches and a programmer or a predator has to find a patch to further forage in, it's called between patch foraging. We use the same analogy here to define the foraging of finding a particular variant. We just call it between variant foraging. The main difference between patch foraging has been reported in traditional literature, and this one here is that in these cases, these patches have all been mostly unique, whereas here, all these variants could be very, very similar. That's kind of the key difference between foraging in general and foraging in the presence of variants. Now, in order to actually find a variant, participants used a lot of different kinds of cues. They used timestamp, which is basically the label that we provided. Remember, I also told you that they were chronologically ordered, so people kind of used that to go this way or the other. And then they used how the game looked like. They used the change log. So what we did was we took the commit metadata, which was the change description, the time at which the change was done, and the author information, and put it in a file within each of these variants. So people looked at that change log. People looked at the source code. In particular, people compared the source code across different variants. And they also looked at the differences in what files were available and the file names that had changed. So they used all these different kinds of cues. And one thing that stood out among all these cues is that they all were literally screaming, what is it that makes this variant different? And I think this is very specific to variations again. It also makes sense because all these variants are very similar to each other. So what really matters is how is this one different from all the others that are around here? So now after the participants had kind of found the right variant, again, it had a lot of different patches inside. So they now have to go and find the right patches within that. People did not go on to find it all over again. So just for the terminology here, earlier in IFT literature, when a predator is foraging within a patch, we call it within patch foraging. We kind of use the same analogy here again we use the term within variant foraging for when a person was foraging within a variant. So like I said, people did not go on to forage all over again within the source variant. They found the source and the destination variants, and they actually saw that the patches were very similar to each other. if you see, there are a lot of patches on both of them that are very similar to each other, even though they were different. Participants kind of capitalized on this similarity between them. Here's an example of how a participant did that. This participant actually had foraged the destination patches on the earlier variant, and he found that there were these calls to a method called render text. So when he went to the source variant, he was like, render text is actually something that I can still look for. So in IFT terms, things like source code words, or basically the content inside a patch, is what is called information features. So if you kind of translate this into IFT terminology, what participants essentially were doing here was they used the information features that they had found in the patches that they had already foraged to kind of go back and find the patches in another variant. So from patches, they saw information features, and they used the same information features to actually locate the patches in the other variant. And in this case, they also kind of implicitly expected that the patches and the information features inside them are going to be similar across all these variants. In some cases, such exploitation of similarities worked. In some cases, it did not, in which case they went to use other kinds of information features, or they abandoned the entire variant, or they just started off over again. So they found the destination patches, the source patches, and now they just wanted to integrate, right? Like take stuff from the source and then put it in the destination to complete the task. At this point, they also did one more thing. They kind of evaluated if the variant that they had found and the patches within them were suitable for reuse. In particular, they looked if the source and the destination patches that they had foraged were similar. This was because they were trying to evaluate the cost of integration. In particular, they all looked for something as simple as, can I just copy and paste? Here's an example of how a participant did that. He found the destination patches, and then he found the source variant. He foraged and then found one. Then he looked for the patches within that. And then he said something like, OK, I can just throw it in because we want it to look exactly the same way. But that didn't work because they were so very different. So he went on to find another source variant. He just ditched whatever he found. And then 3 out of 8 participants actually went on to look for other things, even after they had found the right place, simply because it was just hard to integrate. Finally, people integrated whatever the source and the destination patches to complete their task. So outside of this task completion, one thing that people did as they foraged through all these different variants was they used the information features in all these patches within all these variants and kind of built a story of how the game itself had evolved across all these variants. And they did not just stop with building. And as they looked at more and more variants and patches, they kind of refined these stories as they went along. And they used these stories to guide their foraging. And here's an example of how one participant did that. So he went through a few different variants and said something like, early in the development, there's no score label. And at some point, there is the original score label. And then after that, the second score label is introduced. And then he spent some more time going over a few more variants and then said, after dealing with this for a while, they might have been like no score label, then the original score label, then no score label, and then the second score label. So you can see that they kind of like refined their stories of how things evolved as they saw more and more and gained more information. And as they used, this participant used this kind of story to actually guide his foraging like this. So that's basically why when I hit this version that had no score label, I just decided to start searching in a certain direction, in a more recent direction in this case. And I think this is very unique to the case of variants, especially where things kind of evolve over time. Yeah, so this is unique too. Now, what does this tell us? So we saw how people foraged through all this, right? Essentially, what we did here was to add a variations dimension to the whole information that we have here. And what happens when we add such a dimension is that comparison suddenly becomes extremely important. And we saw that people look for both similarities and differences between all these different variants for various cases. And what this also tells us as tool designers is that we have to consider these kinds of cues, especially when we are trying to design for variants. And finally, we also have this question of where is it that the story belongs in something like the information foraging theory itself? We spoke about a few different constructs, but we don't really know what we should instantiate a story as. Or should we even instantiate it as one of these constructs? It's kind of like an open question that we have. And finally, we have another open question, which again we don't know an answer to, is what is really a useful variant? Right now, it's kind of arbitrary. It's when we save it. And if we have to do it, it's actually also a distraction to somebody who's doing something exploratory and creative. If we were to automatically save it, then we have the questions of what are those right save points? At what granularity should we save? What is too fine grain or too coarse grain? Or do we even have multiple appropriate granularities? We just don't know it. And if we have to save it, then how do we define these changes that went into each of these variants? With that, we conclude. Ours is one of the first studies on foraging among variants. We spoke about between variant and within variant foraging. We spoke about how stories guided people in their foraging. And finally, we had this open question of what is it that makes a useful variant. Thank you. And now it's for questions.
Okay, do we have questions for Sruti?
Hi, Shruti. Nice talk.
Thank you.
Simone Stamm from City University London. One of the questions I had was about the cues that people used for looking through the variants. Can you tell a little bit more about whether there are better cues for foraging between variants? Because I don't think you sort of looked at that. So it's almost going back to Tracy's talk. Are there better strategies for being successful?
Just so I get your question right. So you're asking, are there specific kinds of cues that are particularly more helpful for foraging a variant? So what we just found here is all the cues that we found that people used actually were ones that made the differences between them explicit. We don't really know which one of them was really better or worse than the others. We have some numbers, but I think it still needs a little more study. All we now know is that they should just pick the differences out.